to Fibreseek. We are here in Shanghai. Ryan, CEO.
Hi, guys.
We're going to be taking a look at what's going on here at the factory with you all. And we have a friend here with some 3D printed legs, which is, that's kind of unique.
Hey, say hi.
Continuous fiber 3D printed legs on this Unitree robot dog. Think about that for a second, because these are pretty strong. This is even stronger than how it is stock.
Yeah, our pet is quite popular right now. So
I like them. They're a lot of fun.
Know him.
I say you have another one here, but that one's a real cat. There's a real cat here.
Yeah.
Do they have no audio on stream? Anyways, guys, we're going to go inside. We're going to take a look and see what it takes to get these machines made, right?
For sure, Grant. How are you feeling?
You know, it's been 19 and a half hours of travel. We got in late last night. It is amazing, though. We are psyched to show you all what it takes to build a continuous carbon fiber 3D printer.
And thank you so much for making it all the way here. And we're so happy to have you. I know a lot of our friends online are curious about to learn how the Fibreseek, how we build our machines, right? So I think now it's time to reveal the secret.
Yeah, and this is a real building. This is not fake. I know a lot of people are like, well, that building doesn't look real. It absolutely is. It's really beautiful, honestly. You should come out here one day and check it out. But we have to go inside. Come along with us as we show you what it takes to build these amazing machines.
On it.
Should I just sign out which one?
Okay. It's not on.
No, we did sign it.
Check.
Wasn't plugged in, Amber.
Pulled out, sorry. All right, we're good.
Maybe.
I can hear it.
Can they hear it? Yep. Check. They got it. All right.
You good to go?
So sorry.
Yeah.
Stream's frozen.
It's not the camera. The camera was working.
Nope, it's the camera. The camera's frozen. Okay. Hello? Hi. Come on, follow me. All right, it got me. Nope, it lost me.
Okay, it's back up.
Okay.
Okay.
Welcome to the world of doing things live. Terribly sorry about that. Technical difficulties. We are back now. All
So
right.
you know, Korean, FibreSeek is a new brand originated from an isoprene, right? So, and back in isoprene, we used to make very big machines, and we print very big parts for aerospace, for automotive. So
Yeah,
I think that's where
this
we're gonna
machine's a
start.
little bit bigger.
Yeah.
Just floor demand for scale. I am about 6'1". This machine is taller than me. You will notice this machine has a nacelle on the top of it that tells you its status. That means it's industrial. This is a ridiculous machine. This is industrial grade.
So guys, that's what we were doing before FibreSeek. So
Right.
we were working on these like huge machines, and you can see these parts printed out by this big guy.
Yeah. This is PEEK, carbon
this,
fiber.
PEEK reinforced with continuous carbon fiber.
Yeah, continuous fiber. This
And
is
guess,
not.
make a guess, Grant, what part it is.
I mean, this looks like a wheel for a car, but I know it's not. What is it?
So it's actually a wheel for like a Mars, like exploring.
Oh, for a
cars.
rover.
Yeah.
So this is not like, here, that lost tracking again. There we go. This is not like your regular carbon fiber filled material that you're used to buying, like a carbon fiber filled nylon. There is actually a fully continuous fiber of carbon in here that is a monofilament. This adds insane level rigidity to a point that I cannot break this without hurting myself. And this is PEEK. This is expensive. I'm not breaking it. But with the continuous fiber, you add strength in orders of magnitude. This is a ridiculous part from a ridiculous machine.
So when you send stuff like doesn't matter to Mars, to the moon, right? So you want
It has to last.
it has to be last, but the most important critical thing is it has to be light as possible, but still be strong.
Yes.
So carbon fiber becomes the ideal solution.
And that way you can make this as physically lightweight as possible on the material, but then you add the continuous fiber to make it rock steady strong as possible.
Yeah.
It's kind of crazy. There's no good way to describe how strong this is.
And we do also have some like solar panels. Yeah. So a lot of aerospace applications like through the years, right? So we started been doing this like since 2015. So work with a lot of aerospace labs all around the world. Yeah, and did a lot of like interesting projects.
This is next level. I know a lot of you that might have personal machines at home, that might have a couple of machines, are looking at this saying, Grant, I have no use for something like this. And you're right, you don't, because this machine is just a little bit more expensive than the
It prints
FibreSeeker.
big. It prints a very big print volume, and then it prints high temperature materials like PEEK, PAC, or whatever, and then it adds continuous carbon fiber in it. So well, that's why it's kind of reserved for high-end.
It is your industrial class
industrial
machine.
class.
But you guys wanted to democratize continuous fiber, bring it to the consumer, prosumer, light industrial market. And by doing that, you created
We
FibreSeek.
probably this one right here.
Let's take a
that's
look.
my favorite guy now.
Parts that we can literally throw around and they don't get hurt. It's still something that is unique, is being able to do that, and the machines don't get hurt. and
Yes,
the
here
parts don't
are
get
some
hurt.
like jigs and fixtures we printed for automotive industry.
Take a look at this. This will show you the actual continuous fiber. This is a regular PA6, like a nylon material. You can see the fiber in here. It's harder to see on the PEEK. You can absolutely see it on this. And this is actually capable on the brand new FibreSeeker 3.
Definitely. Yeah.
Strength like you've never seen in 3D prints before. You've never seen strength like this before. I promise you.
Yeah, so here's the new baby.
The new hotness, as it was. This is the FibreSeeker 3, right?
Yeah.
Kind of an amazing machine.
Thank you.
It looks good, and you guys are going to be launching it on Kickstarter
Yeah, we
relatively
do.
soon, right?
Yeah, so we're launching on Kickstarter, and on the very same day at Formnext, like in Frankfurt, Germany. So it's going to be November the 17th. So we're gonna demonstrate the machine offsite right at the Formnext booth.
Okay.
So people could see the real machines functioning alive. And on the same day, we go online to Kickstarter so people could order. Yeah,
Okay.
I'm so excited about it.
And so full retail on this machine, what are we looking at full retail on this without Kickstarter? How much is this going to cost without Kickstarter?
I'm assuming it's gonna be like 2,999.
That's on Kickstarter.
That's after.
Oh, I thought it was
So then
5,000.
on Kickstarter, so we have actually a super early bird price. It's like $2,399, and then on Kickstarter it's gonna be 2,600.
Okay.
Yeah.
Okay. So other continuous fiber brands, you all can figure it out in the comments. That's not me. That's on you. Are 10 times the price to start, just for reference. This has more features, and it's not by some company that just randomly came out of nowhere. A Nisoprint broke off a segment, if you will, for the consumer market. And they branded it something that you all can pronounce properly, because I definitely was pronouncing it properly the whole time. I was pronouncing it a Nisoprint.
Yeah.
It's not. It's a Nisoprint for anisotropic. I learned that yesterday. But this machine is amazing. It is.
That's why I actually come up with a new brand. You know, we wanted to give the product to the wider audiences, right? And then we hopefully want people to pronounce it correctly. And I know anisotropic might be too, like, you know,
Anisotropic. Yeah, most people don't
scientific,
understand
too
it.
academic
Yeah.
word, right? So
Yeah.
And then when we go to like prosumer or consumer, so we want an easier name. So I come up with the name Fibreseek, which I think is like a bit trendy, and I love it.
I like it. I mean, sounds like a good name. It makes sense because it's got fiber in it. And oh yeah, it doesn't have to print their materials. It's a fully open material library. You can print any materials that you want up to 300 degrees Celsius, so that includes nylon, obviously, on a machine that costs less than 5,000 US dollars retail. That's not Kickstarter, that's after Kickstarter. Retail, we're talking sub 5,000 US dollars. That is changing the game for light industrial grade 3D printing. There is nothing else out there, anything like
So it's
this.
not actually intended to disrupt like competition or whatever. So we actually disrupted ourselves. So we used to sell these machines at a much higher price, right? And then we figured we wanted to really democratize this technology. Yeah. So we bring up Fibreseek, and then it's kind of like disrupted ourselves as a Nisoprint.
So where does the name come from, Fibreseek? Where does that name come from?
Well, so definitely one is print fiber, right? So that's our niche. And then so when I try to name the new brand, and I got it, there's so many. Everyone is like maker, everyone is lab. So I try to come up with something different. So and then after like day and nights, and then I thinking about a week. So I'm just like the Fibreseek just jumping out of my brain. So I'm like, okay, let's go with it. Yeah.
I dig it. It's a nice name. It fits the bill. It's easy for you to pronounce. If you're in America, it's F-I-B-R-E, and that just means there's quality to it, okay? That's the quality side of it. Also, I think the camera stopped tracking me, so there, now it's tracking me again. But you're talking industrial class 3D printer with not industrial class pricing.
Definitely.
Yeah. How many of you have used carbon fiber materials before? Let us know in the chat if you're watching live on any of the platforms. Let us know how many of you have used chop carbon fiber. So if you use like a carbon fiber nylon before. And how many of you have used other continuous fiber brands before? Because this is a little bit different. Now, we've taken a tour of the facility yesterday when we got in later in the evening. We're going to show you how this works. But Ryan, I have to ask.
Sure, yeah.
Why continuous fiber? Why go after this market and not a different market?
Well, firstly, we have been doing this for like 10 years. and this is what we are good at. And then we actually saw a lot of potential, and we do have a lot of people who loved our machines. Well, right, but they just couldn't afford it. So every time we went out trade shows and events globally, I personally have seen so many special engineers come and then experience this technology. They're like, wow, I love it. But when you talk about price, they started with like 20 grand and up, right?
They're very
And then,
expensive.
so the vast majority of engineers, they could not like have this decision-making power to to purchase this machine, right? And especially, I think a lot of younger engineers love this technology, but they're probably like 2-3 years in the company, and then they don't have the ability to buy the machine, and then
They don't have the purchasing power
and
or the
that
credit card to
accounts
do
for
it.
like nearly 80% of the
Right.
customers that I've seen.
And if you want to make parts that are both lightweight and strong, there's not a ton out there. Okay. This is a very,
try
very
this one.
strong.
So
You want me to try to break
yeah,
this?
try it.
This is pure. This is just
This is
pure
fiber.
continuous
If you break
fiber.
this, I give this big machine for you for free.
Yeah.
Yeah.
Okay. He did not say that I had a restriction on how I could break it. He just said if I could break it. Oh my God. Okay. I think.
I know what I'm talking about.
Can I do it on my knee like this?
Sure.
You're fine with that?
Oops.
I'll give you my address later.
Okay, cool.
I will tell you that took every ounce of force that I could get. And if you look at this, this is not your chopped carbon fiber. This is actual continuous fiber. And what failed here? You might say, Grant, it broke. Guys, let's go with 110 kilos because I'm feeling lightweight this morning. And I put every ounce of force, like you can literally see the part in my hands. My hands are creased from it. That was over 200 pounds of force, likely closer to 300 pounds of force that I put into this part to break it. This part weighs basically nothing. I would guess this part weighs 5 or 10 grams. You're talking a very, very, very lightweight part. Very lightweight. And so that means that you're getting incredible strength. If this was PLA, if this was PETG, I could break this with just my hands. This took a lot of effort. But when we look at pieces like this, where you're combining continuous fiber and regular materials that you are adding strength to them from anything.
Yeah, this is
on the
actually,
market.
I think, pretty also with chopped fiber, right?
That's chopped fiber with
with
continuous fiber
continuous
inside of it. That's the best of both worlds. An absolutely amazing machine. So you're able, well, that's peak. We can still show it. You're able to determine where the chopped fiber goes. Or, sorry, the continuous fiber, excuse me. You're able to put the continuous fiber wherever you want. So you have a ton here, a little bit here, and none over here. That's pretty awesome. There it goes. Okay. Because it means that you can use the continuous fiber where you need it and save money where you don't.
Yeah, yeah. And also, like, I think the point is you could line up the directions, right? So parts have different loadings, and then you can just design the part wherever you want the fiber to be.
This part here, this is a impeller. Looks like a regular impeller, but when you turn it on its side, half of it is fiber filled, the rest of it isn't.
Yeah.
So it gives you incredible strength for something that is so tiny, right? Now, is this what you guys are going for with this machine? To allow people to prototype and get higher quality parts with continuous fiber at an affordable rate? Is that the idea?
Yeah, that's the idea, right? So I think everyone wants strong parts, apparently.
Here,
Yeah.
we got some samples here. More continuous fiber parts, absolutely beautiful pieces.
Yeah, and you could print the fiber in this like lattice structure. So it saves weight because of the material has high strength but like low kind of like density. And then you could even like make the fibers to go across each other to print a great structure. So it's even structurally more optimized.
It is hard to describe what these feel like. If you've held a pure nylon part before, you know they feel like they're made of air. They don't feel like they've got a lot of weight to them. The continuous fiber adds maybe 5 or 10% to the weight at best. But you're making a part that I have to put the full Florida man into to even get it to make angry noises. And that was a part that really wasn't designed for anything other than having fun. There are parts here that I can stand on. Why don't we get that one that I can stand on and show them the actual strength? I'm definitely not going to hurt myself on live stream. It's fine. It's totally fine.
Okay. So
here, let's show them
that's
this
the one we
part.
printed the other day.
This, now there's a lot of metal on it, so it is kind of heavy here. I'll do the thing again. Oh, well, when I bend down, it'll do it too. This is a full continuous fiber nylon part. Again, I weigh, let's go conservative, at 240 pounds or about 110 kilos. Someone will put it in the chat because they're going to tell me I'm wrong. Put this on the ground. I'm going to balance myself on the table, but I'll try to show you guys that quite literally this can hold a full Florida man who is not the best at balancing. So I am loading this part up as I'm moving around. It's not cracking, it's not creaking, it's not making weird noises. This part is strong. And the metal weighs about 5 times as much as the plastic does.
And I think I did underestimate the power of a Floridan man because I tried to like everything to break that one didn't work out, but so you're definitely stronger than me. But yeah,
we do have to wrestle alligators from time to time. It's just part of the deal of living there. But I mean, this is one of those applications where you could not easily do this with another 3D printing technology that is going to be this affordable.
Yeah.
So then, Ryan, the materials, right? That's always the big question. What about the materials? Because, well, other continuous fiber companies like to charge you an arm and a leg when it comes to the materials. What is your pricing strategy for the materials?
So I think when we try to
It's fine. You're good. Keep going.
democratize the machine, and it makes no sense to make the machine affordable without having affordable continuous fiber filament, right? So I think in old times, like the continuous fiber used to be like $100, right? And then that's almost the price
Easily.
of some like entry-level FDM 3D printer.
Yes. I mean, you were spending hundreds of dollars for 500 meters. Can one of the assistants grab us one of the rolls of carbon? Tuan or Therese, can one of you guys grab us one of the rolls? The small one, Therese. The one next to it?
Yeah.
In the front. There you go. Yep. Thank you very much, our lovely assistant. This is the continuous fiber. This is what you're looking at. This is a 500-meter roll.
Yeah.
How much is this?
Make a guess.
I know the answer.
Okay. It's gonna be like, and we got these questions a lot. So yeah.
Guys, in the chat right now, live, if you're watching, how much do you think 500 meters of carbon fiber monofilament that goes inside of your parts? What do you think this costs? What do you think? Let us know. What do we have? Do we have any answers right now coming out of the chat? Nothing? I think people are cheating. I think it's public knowledge.
Yeah.
We got 50 and we got 250.
50 and
Okay.
250. Well, one of them is right, the other one is wrong. Do you think that 50 is the answer or 250? Because this is 500 meters. It's a half a kilometer. Half a kilometer. 250 is not right.
No.
This is
that was the old
$50.
price. Yeah, it's $49.
$49.
So Unigram and guys online. So before we spent like starting development for this new machine, right? We actually started developing the new impregnation technologies for the fiber first. So it took me almost like a year to figure out how to fabricate like this filament, right? To process this filament. So you have to actually to mix the raw fiber and then like through a very long process. So because the raw fiber, like it's like your hair, and you cannot
It is very
print
thin.
it directly.
And the raw fiber on its
Yeah,
own is
yeah.
not all that strong.
No. So you have to like, pre-treat the
Yes.
raw fibers, and then it's like a lot of process. So we spent a year to upgrade our manufacturing process and then also the capacity, just to really make this filament affordable. So after we realized we are able to, deliver affordable filaments, then we started the development of the affordable machine actually.
But you're doing something different. You're not pushing that fiber into the part. You are inserting it into the filament coaxially as it is coming out of the hot end.
That's right.
So you are not just squishing a carbon fiber monofilament into it, you are embedding it coaxially, so you're getting the best amount of strength possible. Yeah. By the way, that's patented.
And then that's
They
a
own the
kind of like a
patents.
unique patented technology, right? So, so since we have a co-extrusion, so you co-extrude this filament
Yes.
together with a spool of like regular FDM filament. It could be PLA, it could be PETG or like PET, right? It
Yep.
could be like nylon or whatever. And so whatever filament you co-extrude it with, and then you can print also the base material with this co-extrusion filament. So you just only have to buy one fiber, one kind of fiber, and then it's compatible with all kind of like base materials, all kind of FDM filaments.
So you're telling me that if I get a Fibreseek, or anyone here that might back the Kickstarter campaign, the only thing they have to buy from you is this, and that's only because nobody else makes this.
Yeah,
This is your guys' proprietary
Right.
material, and now you have co-extrusion as well, so you have two hot ends to be able to use dissimilar materials, some with fiber, some without fiber. And you have a full open materials library.
We do.
So I'd like to point out that other brands in this industry are going to lock you into their materials. They might have NFC or some sort of DRM. Fibreseek has said no.
What's this
Why?
like? We have been, open the materials since in isoprene, right? So at isoprene, we work with a lot of like labs globally just for like material sciences. And then isoprene machines became a very popular like scientific R&D tool. And then universities and labs globally like have isoprene printers to do like a lot of research. And you can see a ton of papers published with our machines. So we have the spirit of like open material options. So it doesn't make sense when we go Fibreseek and then we just like closing everything down, right? It doesn't sound right. So I mean, we do offer our like plastics filament as well to make it easier, but we're not like restricting people from using
That's a big
Open,
deal.
like-
So you're getting an industrial quality machine without the industrial quality headache. The industrial quality headache being that you are forced and required to use their materials that they charge an exorbitant amount of money for, that nobody wants to spend money on. So the technology, the machine sits and collects dust. Fibreseek said, no, we don't want that. We want you to use the machine as much as possible.
Yeah,
And because of that, we're going to give you an open materials library.
right. And it's like I know some people already have like filaments at their home, right?
I have
So
literal tons of filament at home, yes.
So you could just reinforce your filaments at home with this fiber. So that's it.
So
idea.
you guys heard it here. You don't need to buy fancy special filament. You can literally use the filament that you already have at home. Yes, please use nylon, use high-end materials, play with continuous fiber, but you don't need to. You can use PLA with continuous fiber because reasons.
Yeah.
Because PLA is not stiff enough. You will need it to be extra stiff. There are jokes that I can make for that, but none of them are appropriate. When we look at the goals for this machine, what is your major hope that people that get these machines, that back the Kickstarter, that buy them retail, what do you hope they make with this?
I think we have like quite obvious like applications, especially for people wanting to print, like for myself, like to print drones and then to print RC cars, right? And then, so I'm also like karting person, so I would print parts like, and then just to customize like my kartings time to time. But I'm actually quite curious because I know printing strong parts, I think it's like of need of basically most of people, right? And then, so before, when you think of print strong parts, people automatically assume, okay, we have to go like metal, or either you do like metal CNC, or you go like metal 3D printing.
Right.
Yeah.
You run into this wall of, I want to use 3D printing because CNC is very expensive, but you run out of technology with 3D
Right.
printing. This makes it so you don't. Jacob, what was the karting company that we visited with in the UK? Harvey Motorsports, they utilize 3D printing at their facility. Continuous fiber would add so much added strength to high-end karts. They make some of the world's fastest shifter karts, like 150 miles an hour on a straight. It's pretty awesome. Oh, did my computer just die? Okay, well, is what it is. So let's go ahead and move on to the next location.
Sure.
Let's show them what else is going on.
So I can show you like how we making these big machines here. So
Okay.
we do have a more of like this big guys.
Okay, yeah, let's see it.
And here you can see a bit more of our like facility.
Yeah, it's a, our camera's gonna have a hard time panning up, but we're in a massive atrium right now. It's quite large. You can hear the echo most likely to see it. But if I take our stream camera and I point it up, you guys will be able to see just how large this facility actually is. And oh yeah, they're still expanding into the rest of it. Let's see these big machines and
Yeah,
how they're
yeah.
made. That's fine. And we have power over here, by the way. Can we show this in the background?
No,
No?
just this.
Okay. All right. So these are the big prints.
Yeah,
These
that's
are
the
the
big
huge
printers.
machines. Can I open this door?
Yeah.
Am I allowed to?
But I think this one is printing and it's high temperature, so.
It is currently printing. I will not be opening the door on that because that is going to burn.
So it has
A
a
lot.
temperature of like 200.
Yeah, 200 Celsius. Let's see. Can
80
we see
probably.
something on the screen here? I'm trying to see if I can see temperatures. I can't. I can just see raw G code. Darn. I was going to try to see how hot that machine is. It is exceedingly warm. Exceedingly warm. But that's how it goes. When you're printing high temp materials, you need to have high temp machines. It is a requirement. So can we talk about these machines for a little bit and how you guys said, huge machine, very expensive, but then went to small machine, very affordable.
Yeah.
Can we talk about that?
Yeah, sure.
Sorry.
Yeah, I think these machines.
We're having technical issues. I'm sorry.
It's all good?
Yeah, we'll make it work. So let's talk about this machine for a little bit.
Yeah, so we, I think we introduced this machine to the market around like 2020.
2020, so
Yeah.
this machine's been around for a while. But this is quite a bit larger than the FibreSeeker 3 machine.
It's
Literally, I think the FibreSeeker 3 fits in the window.
in the there, yeah, in the print.
Why go from huge machine to small machine?
Well, I think just to be able to have the ability to for like more people to try it. So I think when we're working with the big machines, we spend so much time and energy to trying to develop the application. So and you have to sit down with like organizations and well develop and then test this like printability with this machine, and then it just takes so much time. And then we did achieve to, and we worked with a lot of organizations globally for like some like cool projects, right? But I think the idea of like developing application was kind of wrong.
Okay.
So that's my personal conclusion. So I think the best way to, because we're giving the market actually a disruptive technology. So 'cause you see, 3D printing has been around for like almost 40 years.
It has been around longer than
matter,
I've been
like, yeah,
alive. Yeah.
Doesn't matter if FDM or like SLM or like SLAs. They're been around like 40 years.
Right.
And then continuous fiber technologies, 3D printing has been only for 10 years. Like,
It has not been around for very long.
so even like 3D printing are still considered as a younger technology comparing to like traditional manufacturing technology, saying a CNC or like molding or like injection molding or whatever, right? So 3D printing is like young. Even it's 40 years, but it's still like a
it
young
is
guy.
still like, think about
Yeah.
the internet or personal computers. Personal computers have been around since what, the late 60s, early, well, computers have generally been around since the late 60s, early 70s. And we are still seeing massive advancements. I would say that going from a huge server style machine to the FibreSeeker 3, which is more akin to a cell phone. It's reasonably portable. You can pick it up and move it if you need to. I would give you one of these if you can pick it up with your bare hands, because I know you can't. Don't hurt your back, kids. I've done that before. Don't try that. But you took all your learning from this and an isoprint and put it into FibreSeek.
So to my understanding, if 3D printing, like it's still a young guy, right?
Yes.
And then continuous fiber 3D printing is like baby. So and then how to market this like disruptive technology? I think the best way is to make it affordable. So and then I know it's a disruptive technology, so you have like different kind of habits,
Right.
a different way. So people have to get used to it, right?
Right.
So I think the point is when it's more affordable, it gives less risks for like people to try it. And because I've seen like almost everyone want to try this cool tech.
I mean, let us know in the comments, do you want to try
Yeah.
this kind of cool tech? How many of you even used continuous fiber before? It's not a very common tech.
But if we're starting with this one, so how many could like have the ability to try it, right?
You can buy a very small house or one of these. They are roughly that level of price. And you took all your learning from this and put it into
That's
the
right.
FibreSeeker
Yeah.
3. It is
So
amazing
people
to
could
see
try
that.
this tech like with like no risks, right? And it can like run as a 3D printer, like FDM, and then
Right.
you have this option to print with carbon fiber. So I'm curious to see what applications like with FibreSeek people gonna develop, people gonna try it out with. So I think we learn from the people, right? So we're only the machine manufacturers. So we cannot think of how to apply this technology in all kinds of aspects because people all around the world, they're making different things,
Right.
for yourself, for
Right.
your organization, for your like business. But I cannot comprehend what strong parts everyone are making.
Right?
And
We-
then being able to have this FibreSeek 3, which whoever wants to print a big parts, you could just like afford this machine and then try it yourself. And then more trying, I think more possibility, more doors going to be open.
So where does the name anisoprint come from? Because I've been mispronouncing it. You've made FibreSeek easy to pronounce, but I know there is a story to the name.
Yeah.
Can you tell us the history behind the name anisoprint?
Okay, so an isoprint apparently, if people who took material science class,
Uh-huh.
they would like study. For material, there's a difference. There's an isotropic material, and then there's isotropic material. So isotropic material is basically like metal. So you have, same strengths in all kinds of directions,
Right.
right? But with anisotropic material like carbon fiber, so you actually, its strong strength is at its best along the, direction of
Right.
the carbon fiber. So it's like here when you pull it, it gives you the best strength.
Yep.
But if you try to break it from the vertical direction, it's not that strong. So it has both sides. So if the point is, if you design the anisotropic material like fiber, like wood is also an isotropic material.
Yep.
Right? It gives you the really good property.
Yes. Yes.
So anisoprint would be like the best way to print out anisotropic material. Because
Right.
you can print carbon fiber like the part I showed you with grids. And then this kind of like counterbalances the unidirectional limitation of carbon fiber. So
Right.
anisoprint was invented to print out anisotropic carbon fiber. So that was the term.
Now the name makes sense to all of you. They're like, what? An isoprint, an isoprint? Why? Anisotropic 3D printing. Put them together, you get an isoprint. Makes it easy. Fibreseek is just one that you guys can easily understand and not screw up too much on the spelling side of things. And it's more of the consumer brand, the democratization brand. This is industrial. The part that is printing in here, I can't exactly see what it is made of, but I can feel the heat. And this is very well insulated.
Yeah, it's PEC, and then with continuous fiber.
Oh, this is
PK.
PEC.
Yeah.
Because of course it is. Because of course it is. Jacob, turn the computer monitor down in. Okay, just making sure. Yeah, this tech is pretty amazing.
So I think since the main character today is Fibreseek, so why don't we go upstairs and I show you how and where and how we're making these Fibreseekers. Shall we go upstairs?
Yeah,
Yeah.
you're good. Okay. All right. Yeah, let's go up. Huh? Oh, you want to? You want to? Oh, this one's open.
Okay. So we go this first and then we go upstairs.
Oh.
Okay.
What? Yes, there is a move that is going to occur. Yes. Oh, we can see into that machine? Oh, we can see. A hot end? Wagos. Okay. So before we show you inside of the machine, these are all drying bays. With individual PLC controllers, dang it, because that's the right way to do it. This is really nice.
Yeah, especially when you print pig, you really wanted to heat it up, keep it like dry.
How hot can these get? How hot can these individual chambers get?
I think like 100.
100 degrees Celsius. So even high temp materials can print in this without an issue at all. That's tremendous. So let's go check out inside of a machine and show you what they look like. Because this is very thick. The window is very, very thick. And if we take a look quite closely, this is what industrial class 3D printers look like. They look kind of boring, and that's the point. Because boring means reliable. What do we got? Toe?
Yep. Felix Walking Solutions asked us to explain the word toe.
I've never said the word toe, I don't think.
I don't know.
Yeah. Asked us to explain the word.
I think
what
it's
toe means.
probably the
T-O-W.
referred to like carbon fiber toe or like toe brag. So
To like tow something with
brag,
carbon
toe,
fiber?
Toe brag. It's like, so you like the material I showed, right? So it's like a carbon fiber toe brag.
Okay.
So we mix with the raw fiber like a hair, and then you would undergo like impregnation.
Oh, yes,
process.
that's right.
So it become a carbon fiber toe brag.
Correct.
So we don't print. Were like technology that print with raw fiber. So that, but that was like in the very beginning when people research about like
Right.
raw fiber. We actually tried it out before the Toprak. So we printed out with raw fiber, but and it didn't work out.
Okay.
Yeah.
Yeah. So they're using like a pre-impregnated
Yeah,
material to
like-
help it bond better.
So it's a Toprak co-extruding.
This is where the business end is. If you'll notice, if you guys can see it on the stream, we've got servo motors with full like knowledge of where they are in the world. Everything is made out of thick I-beams, huge rails, and all of the chamber has a wiper system in it so that the heat stays inside of the chamber. These machines can get incredibly hot, and that makes them able to print high-temp materials. Glass build plates, a lot of you might remember those days, but it is still the best material to print high-temp materials on, right?
Yeah, and it's got like 4 pneumatic like tool changer.
Oh, it has a
So it
pneumatic
has,
tool
like,
changer.
Up to 4 print heads.
Because of course it does.
Yeah, yeah.
So you're bringing in things from the CNC world to have a tool changer in it
Yeah.
into the 3D printing world.
So we have like 4 print heads, right? So we have one to print like the base material, and then we have one to print like kind of like solid with support,
Okay.
and then we have 2 other print heads. They can print different like fiber of different thicknesses. Yeah. So these 4 print heads like they work one by one, and you can swap them like through this like pneumatic industrial like tool changer. So they go like up and down. Yeah.
I've seen it work. We might have some footage for you in upcoming videos that we're going to be filming here at Anisoprint and Fibreseek. So stay tuned, get subscribed to the YouTube channel and all of that if you want to see those kinds of things. But I will tell you that these machines are unlike anything that I've ever seen. I've been around industrial FFF and FDM machines for years. I've operated big machines that have an F as the first character in their name. I don't like to mention other brands when we're working with brands. I'm sorry, it's the way this works. This is bigger, faster, stronger, more affordable to run, more affordable to fix, more affordable to upkeep, and just generally more affordable and easier to use. And yes, it's expensive, but when you compare it to everything else on the market, it's not. And so Anisoprint has taken a lot of that knowledge and put it into Fibreseek, where you guys are democratizing continuous fiber machines.
Yeah, it took a lot of, experiences and a lot of learnings. So up to this point, we finally felt confident that we could like take this like huge step forward with Fibreseek.
Now, when did you start with Anisoprint?
So that was about like 5 years ago.
Okay.
Yeah.
You've been doing this for quite a bit then.
Quite some time.
Yeah.
Yeah.
It's very interesting to see this. Is there... Oh, we have a part here that we can show. And we've got... Ooh. This is the continuous fiber used
I think
in the
this
big
is high
machine.
temperature filament, right? Yeah.
And this is...
Yeah.
Is this
it's a-
Ultem or is this Peak? I think it's Ultem, isn't it? Is it PEC? It's PEC. Okay. PEC. Polyether ketone ketone. PEC. Materials that you can't print at home.
So
But
pack
you-
is
you
a
just
little bit
can't.
easier to print compared to peak. Yeah.
Okay, but that's like saying
quite similar.
you go from the hardest material to the second hardest material.
Yeah.
Yes, it is easier to print, but it is still
Little bit.
very, very tough to print.
Yeah.
Yes. Yes. This is amazing to see it, and of course, continuous fiber in it, and then no continuous fiber where you don't need it. It's pretty amazing. It is absolutely, absolutely amazing. Do you guys have any questions before we move up to take a look at the facility upstairs where the Fibreseeker 3s are made? Do you guys have any questions? Any of the chats got questions for us yet? Nothing?
They're a mess. Well, it takes a second. We gotta let.
Right, yeah, that's fair.
About like seconds.
But that is what they meant.
Oh.
But
I'm used to like
30
8 seconds.
I would like you to again repeat the pricing for your Kickstarter. Something we didn't like.
The pricing for the Kickstarter on the Fibreseeker 3. Yes.
So for the super early bird price, like it's like 2,399, and then on the Kickstarter is like $2,699.
Thank you.
That's really affordable, guys. Like you're talking continuous fiber for, I don't want to say another brand, for very large green brand money. Okay? You're talking continuous fiber 3D printing for very large orange brand money. And you're getting larger build chambers, better parts that you can't do on other machines, and strength like you've never seen before. That part that we snapped, if that was made out of pure nylon, or even the fiber-filled nylon, the chopped fiber, you can bend it. If it was raw nylon, you could literally bend it in half. Raw nylon doesn't like breaking. Chopped fiber nylon would have broken much easier because you're trading carbon fibers for plastics. With a Nisoprint and Fibreseek, you don't have to make a choice. You get both because the continuous fiber is added coaxially to the filament. It doesn't reduce your interlayer bonding.
Yeah.
It doesn't reduce strength. You get the best of
I would say
every
like
world.
chopped fiber actually gives better surface finish than
That's true.
strength, because it
That's
gives
true.
you more like Young's modulus, right?
Yes.
And then it kind of flows much better, but like doesn't necessarily give the strength, but yeah.
We have talked about it on a recent podcast where we said that if you want your 3D prints to look beautiful and you don't want to work hard for it, chopped fiber, just do it and your parts will look beautiful, even if your printer doesn't do very good parts. Chopped fiber makes parts look better, and to get parts that look this good with continuous fiber is pretty darn awesome. We have another question?
Yes. What are they using for bed adhesion in the Nisoprint?
What are they using for bed adhesion in the Nisoprint? It depends on the material that you're using. So it can be anything from nanopolymer adhesive. We've seen other things out there, but it will depend very much on your environment. Shanghai is very similar to Florida. It is warm and humid. So you will have to do a little bit more prep work here than you might if you live in the desert or in an area that isn't humid. So different materials require different specs, but is there a recommended bed treatment for the Nisoprint or the Fibreseek machine to make the parts stick a little bit better?
So I think with FibreSeeker, right, we have actually the epoxy like print bed, so which is quite compatible with quite variety of like different filaments.
Okay.
Yeah, but we also have like PEI kind of bed, and then I think we later gonna release like a print bed with like different treatments. So if you like specifically wanted to like adhesive, it sticks better with like PLA or like PETG, I think we could also do something like that later.
Love it.
Yeah, yeah.
Love
But,
it. Love
we
it.
generally this one right now we on the market is like the epoxy like print bed. So.
We've used some epoxy print beds before, and they really grip the high temp materials. So hilariously, when we use epoxy build plates, we always say to wipe them down with an ammonia-based glass cleaner, because that helps not only get rid of any oil that's on the build plate, but it also provides a thin film layer so your parts don't weld themselves to the build plate. But I'd like to point something out. A part like this, from a business perspective, you could sell, assume this is nylon, something that could be made on the Fibreseeker 3 machine. You could sell a part like this for well over $200 US to a manufacturer that needs it and needs it fast. So it really doesn't matter what the build plates are, because that can easily be called the cost of doing business, because build plates are not expensive. And at a 300 millimeter XY,
Yeah.
it's a well-known size in the industry. They already
Actually, we
exist.
calculated, if you could print some parts, I believe it definitely could like replace some CNC machine parts.
Oh, for sure.
And then the return of the investment, it could be like 3 to 5 prints.
Oh, yeah.
Yeah, I mean, like if some parts completely lacks shape. Yeah.
We have another question? What do we got?
Oh, we actually do. Yeah.
So there will be a heated
There's
chamber
going to be a heat
add-on?
chamber. So
Okay.
yeah, and because I think we have a lot of feedbacks since we like did the pre-launch.
I want
so,
the
you
heated
know,
chamber, yeah.
Since we like when we first launched, it was not like the final
Right.
design yet, so it was like the design verified like version, and so we actually wanted to bring out some information to the market and to collect feedbacks, to hear the voices of the customers, and then everyone talks about heated chamber. I'm like, that's not the hardest thing to do, so we're just like add heated chamber. So I had an engineering meeting, so I'm like, guys, just let's put this on. So that's easy.
But this is the value of beta testing and the value of
Right.
Kickstarter, because you're able to get feedback from beta test users. There are FibreSeeker machines out in the wild already. And I have on good faith that one will be showing up at 3D Musketeers relatively soon. So if you want to see what Florida Man does with a continuous fiber machine, and I
That'd be
promise you, you're going to want to see it. It involves gasoline engines, and that's as far as I'm going to tell you. And it also involves trying to see if we can beat a continuous fiber part with anything off the shelf, including metal. Because I think a continuous fiber part, if printed properly, is stronger than a steel counterpart at the same size, and specifically the same weight, because it's much, much lighter. But yeah, heated chamber, very much like them. Another question.
2 questions. One is, when will they FibreSeeker be released? When will they be shipped? And the other one is, they want FibreSeeker guy who seems to know lots of information. They want to get a background about what we do.
You got myself? Okay, so
So a bit of background then.
okay, I could I can let me address the first one about like shipping, right? Yeah. So we could like later go upstairs. So we're already doing the like test production. So we have the assembly ready. But like, well, since we are doing actually another iteration of like adding some features, like for example the heated chamber, right? But that's not gonna take so much time. So it's just a bit like
There's a lot of manufacturing behind the cameras that we're not able to show on camera, not live at least. They have the engineering capabilities to do this. I can see it.
So the launch gonna be end of November.
End of November.
Like mid-November, around like Formnext, right?
Formnext time, yeah.
17, and then we can launch it for a month. Yeah, and then in like the target is to ship the first batch around like February, before February.
So Q1 2026, looking at getting these machines out the door to you guys, backers on the Kickstarter.
So we want to ship the first batch of machine, as many as we can make before the Chinese New Year vacation. That's
right.
the deal.
Yeah, that's fair. We don't get vacations. What? I didn't say that. And do remember, obviously, it is a Kickstarter, so it's money that you are willing to take a risk on. If you don't want to take a risk, you can wait till the machine goes on sale to the general public at a higher cost. There is no guarantee. We are literally standing here, and I will tell you there is no guarantee. But this is pretty darn close to a guarantee that I can give you. I know that we are going to be backing the Kickstarter as soon as it drops, and now we know when it's going to drop, so I've already set an alarm in my phone. I'm not weird, you are. It is something that we look at and say, from a business perspective, we would love to have this technology for not this price. And we are getting very close to what this machine can do on a smaller scale.
Yeah,
For
I think
literally
I
one
guess since
20th
people
of the price.
like a bit about myself, right?
Yeah,
They think you know a lot of stuff.
Oh, thank you.
he knows a thing or two.
I know something. So I have a background of like mechanical engineering, and I'm doing also like a PhD in like smart manufacturing.
Okay.
Yeah. And so I joined an iSpring like 5 years ago. And then since we were at that time, we were still like in Luxembourg, right? Yeah. So I was in charge of like part of like manufacturing and then the market for like Asia Pacific. And then 2023, I had opportunity to rebuild like the company, so relocate the headquarters to here, and then we build a much bigger like team, and we got a lot more like VC fundings. Yeah. So and then I took over, so I took the CEO role and then lead the company up to this point.
You've made a lot of changes since you came in.
try.
What has been the most impactful change that you think that has brought Fibreseek to market in the way that it is?
I think definitely the user experience. Yeah, so that's the thing that I really care when when you're trying to democratize the technologies. So you really wanted to make it easier
Has to be easy to
understand,
use,
right
yeah.
from not just to use, actually easier to understand in terms of design, and then in terms of slides, because the slicing carbon fiber reinforced part is different than slicing FDM part, right?
And you guys have your own slicer for this, right? This,
We do.
Is there a chance?
And we developed a new slicer just for FibreSeek.
Okay.
So, because when in an isoprene slicer, you do have to have some like quite some knowledge of how much fiber and what to play around with parameters. But with FibreSeek's new software, right, and then we try to make it easier to understand, more intuitive. And that is not only for the software, but also for like the interface for the machine. Right. So this one you don't want it to operate, like yeah.
This one is an actual computer. I can see
This
Microsoft
one you have
Edge
to like,
and
we have to charge you for
Acronis.
like 2 days training on this machine. So
I mean, we're here
Yeah.
all week.
yeah, that's just kidding.
I know.
Yeah, but for like the FibreSeek 3, I bet like you don't really need like training. So the user interface is quite intuitive. So you could just like pick it up by yourself.
It is
Yeah.
literally so intuitive. When we were getting a tour yesterday, so we had some plan of what we were going to do today. They put me in front of a machine and said, use it. I said, but it's not in English. And they said, oh, yeah, here. One swipe, one click, boom, I can now read it. It is that intuitive. And then I went through the menus with no training whatsoever, and I knew exactly everything that we needed. And yes, before you ask, you could air gap it. That's the nice thing about these machines. They are designed from a company that manufactures industrial grade machines for a consumer market. They've already taken these things into account, which we like to see. We like
And
to
we
see
added
this.
all the automation features, so like you don't have to do any like manual calibrations like before. Yeah.
That was back in the day, back when things were difficult. Now 3D printing really is just click, print, go, and you guys are really kind of changing that game. Now, we talked a little bit about challenging yourself, right? Challenging the company to do things differently. How do you think that's impacted the way that everyone that works here thinks when they go to work every day? Do you think that really changes the way they look at challenges?
Well, definitely. So I would say it's quite like a big shift to the organization to move like, because like B2B world is like vastly different than the
Right.
like B2C world, right? But I think it's the great thing is like I have like quite like a team of many, young engineers who are very passionate and energetic. So so when I first introduced this new idea of like FibreSeek as a company, I was like most of them are very passionate, so they got like ignited from day one. Yeah, I think
Passion's
people are really
difficult to find.
passionate and then about like
Air compressor. It's fine. We're in a factory. This is part of the deal.
so if they're able to like bring this machine and then they see like a lot of people using them, training with them, having fun with them, and then have like creating value for people, so it's very exciting. And then I think it's like it's a more like self-fulfillment, right?
Right. Right. There is so much more to see. Are we
Good
ready
to
to
go up.
move? Are we
Okay.
ready to be mobile? Here's the plan.
So y'all are gonna go ahead.
Okay.
We're gonna take the crowd on a trip on the elevator to meet you up there.
Okay.
Good.
Just if you want to let them know that we're gonna
Yep.
split. for a
Okay.
second.
Okay, we're going to split up. If you are watching over on the FibreSeek social media, you're going to follow us upstairs. And if you're watching on 3D Musketeers, enjoy the really awesome glass elevator.
There might be music.
There might be music.
Yes, listen.
I expect you to sing and I expect you to dance.
Nothing copyrighted.
No, it's not gonna pick up.
It's fair use. We're fine.
If you get motion sickness, don't look for a second.
Yeah. We'll see you upstairs in
See you
just a
upstairs,
few
guys.
seconds. Let's take a walk. This is all live. Sorry, guys. I know this is a little challenging.
That's how we proved we're not a 3D rendered picture of the factory.
Honestly, even I thought the factory photo
That's
was a
funny.
3D render. And then when we pulled up yesterday,
Yeah.
I'm like, oh my God, it's not a 3D render. It actually looks like
Yeah.
this. It was amazing to see
Hopefully
it.
people are not gonna say like we are 3D and not like AI generated,
I mean,
like by Sora.
I mean, are you real?
I
Am
don't
I
know.
real? Are you guys
Maybe.
real? I don't know.
Yeah.
That's an existential crisis question for later.
Yeah.
You want to walk up the stairs, probably? Yeah. That's probably better for us. That way they can take the elevator.
So they're taking the elevator, or I think.
Oh, you
Yeah,
want to
maybe
take it as
we
well?
could,
Okay,
yeah.
let's go. And then you'll bring it back down for them. Ooh,
That's actually my favorite elevator.
We'll see you in a second.
See you guys.
We have to look cool when the elevator closes. We could do our own music. Oh, you're gonna come in? Oh. Bye. Nope. Oh, well, maybe not bye. Well, hello there.
We don't want to lose the stream, so just in case. We've got battery, but
Okay.
you're good. Don't worry. It's not up her nose.
You better like and subscribe. I can hear them laughing, which means they're hearing us. Oh my gosh. We're going this
So
way?
we go this way?
Yep.
Yeah. We come to the second floor, guys.
Welcome to R&D.
Yeah, so that's our R&D office.
We can't show too much in there because it's for research and development purposes. Yeah. This is the most amount of cameras I've ever had pointed at me at one time, outside of going through customs. I'm gonna keep walking backwards. Maybe it goes well, maybe it doesn't. I take full responsibility. Welcome to the factory floor,
Yeah. So
where
come to this
literally
assembly line.
the machines are made.
So maybe we can show a little bit here first, and then we're gonna go around, see how
Sure.
they're assembled. So here are the final like testing zone, right? So that's the machines like out of the shelf from the assembly line, and then we put it here. It's just for like.
Oh, this one's actually running.
test-
I didn't
for
realize it
testing.
was running too.
Yeah.
Wait a minute. I thought this was just a status light. This is a print progress
Yeah,
light, isn't it?
It's like progress bar. Like I
Oh
personally.
my gosh.
I personally designed it. Okay.
Dude. This is an LED. And from what I've seen,
Yeah.
what am I supposed to...
Okay.
Huh? You
Yeah.
want me to open this, or... Okay. Oh, no, it's running right now. Okay, that one's running too. All these machines are currently running and they're in testing. So if you want the most amount of proof that we could literally provide you with that this is not a first-time company that's never done this before, here's your answer. This is a manufacturing floor here in Shanghai where machines are being tested, where they're running, and we're making functional parts with continuous fiber live.
So with this like shelves, we could like each time like has like 200 machines. Yeah. So they can test there here 200 machines, and then a pack over there, and then like yeah. So but we do like thorough testing, like footprints before we ship every single machine. That's how it works.
It's pretty awesome to see the machines running. And it's like, I guess this blew my mind when we saw it, because I expected maybe like 5, 6 machines. No. There's 1, 2, 3, 4, 5 rows of racks, and they are 1, 2, 3, 4 deep. So there are 20, is that good math? That might be good math. 20 of these racks with machines on them in some level of testing. You guys are taking this seriously, even
Definitely.
before you've launched the
Yeah.
Kickstarter.
So we wanted to test more because right, like the democratizing machine is not as easy as it sounds, right?
Right,
It takes a lot
right.
of. You want to make sure, like personal users, like could actually use it without like headaches and things. And then so the more you test, the more problems like you could find out. And then especially like you will always find out like unexpected problems. So even before the launch, we already had to make like 100 machines, like and
You
then
have
we
to test.
test
You
as
have to
much as
test.
we could, like to fine tune every details. And then even we have more time after the launch, so we feel like it's gonna be like more prepared. Yeah.
Yeah. I'm sorry, I can't get over this light.
So you want
What's
to?
up? Do you want to show one that's running?
Yeah. For sure.
We're printing something that I can't legally own in the United States, but we're not going to worry about that. This is an actively printing FibreSeeker 3. And this is full speed, okay? Here. My watch is right here. If you zoom in enough, you might be able to see the actual seconds on that. But this machine is running at full speed. I'm looking on the screen. Nothing tells me that it is running over what it should be running. These machines are running stock settings and stock speeds, and I can literally see the inside. That is so...
Yeah, it has to clean up the nozzles
Yep.
before it switches.
Especially with nylon?
I think it's PETG with like continuous fiber. It's PETG. Oh, see, now it's already
I'm
back.
reading it.
Yeah, it's PETG.
Is it PETG? It's
Yeah, it
really
is.
clear.
Yeah, it's PETG. Now it's laying the fiber. So that's why this is orange. And then you see there's some like purple and then there's some green, right?
Yeah.
So when you like print carbon fiber reinforced plastics, so use both nozzles, it gives you an orange load bar. So you not only know how much it has been printed and you know what kind of part you're printing. So
This is still pretty... Okay. Not many people do this. Okay, here. I'll just do that, and then... okay, good. Whatever. You're following me now. One more time. Okay. Sure. It is one thing to have an actual, like, light on the machine that tells you what's going on. It's a whole nother thing for it to be a status bar to tell you what you're printing and where it is in the process. And you also have lights inside of the machine.
and it makes the machine looks better, doesn't it?
It does. It makes it look a lot better. Yeah. Now, it is moving quite slow with the continuous fiber. Why does it move slow with continuous fiber?
Well, because you want to make the fiber gonna be like dragged.
Right.
Yeah. But we actually tried our best to increase the fiber printing speed. So it's already twice the speed than we did with the other like old machines.
And yes, this is running a little slow. But again, when you are embedding a continuous fiber filament into the middle of a 1.75 millimeter filament, you don't have a lot of room for error. It has to be done right. Because if it is too far in one direction, things start to break down quite quickly, right?
Because you know, cause FDM is like glue gun, right? So you're melting the plastics, and so you could just go as fast as you can, as long as the it goes, right? But with fiber, it's not like you don't melt the fiber. So with chopped fiber, you can melt it because it's like small particles.
Right.
Right, but with continuous, you have like complete full strand, and then you cannot melt them. So you have to lay them like with like complete structure. So then you want to make sure, and you have to cut the right corners like precisely.
Because if it
So
doesn't,
it takes a lot of control, right?
if it doesn't, the fiber actually can get pulled out.
And besides, when it's not only print, and then actually the carbon fiber, continuous fiber nozzle, it acts like iron. So you pull out strands, but you actually iron it, like to press it like,
Right.
tightly with the other layers.
What is your... Huh? I'm not... So are the mics dead or what's going on? Talk to me, Goose. Is it back up and running? Do you want me to take a look real quick? I don't... What would you like me to do? Okay, we'll keep going.
It's good? You good? Yeah,
We're
yeah.
switching between APs. It is a challenge to live stream anywhere. It is a extra challenge to live stream in China. So, please bear with me. This is not Spectrum Internet, but it's pretty darn close. That's a joke that my audience will get.
Okay.
Uh,
Yeah, so
It's so freaking cool. I'm sorry, it's so
almost
cool.
like complete the layers of carbon fiber.
Mm-hmm.
I'm assuming it's gonna switch back to the plastics,
right.
right?
Now, do you have to use the continuous fiber nozzle for continuous fiber? What if I wanted to just print, say, I don't know, nylon and PLA in the same print with no continuous fiber? Can I do that?
You can. So that's like some of the printers go with like green, right? So you could just
Mm-hmm.
print with like plastics. So the point is, even the continuous fiber is a bit slower, but you don't have to like use a lot of them if you don't make like super strong part.
Right.
If it's just a strong parts, I think only a few layers of fiber, and then you like will be good to. Yeah.
But if you want super strong
Yeah.
parts, it takes a little bit of extra effort.
so
to say
it's an
the least.
option of how much
Mm-hmm.
fiber and where the fiber to be put. Yeah.
Everything okay, Amber? Huh?
And you
Okay.
can put it like no fiber, and then this is gonna turn green. I like some of these printers.
Yep. Yeah, there's one back
It's
there
just
that's
gonna
green.
become like a regular FDM.
This one's doing fiber. That one's.
Yeah.
I-
And if you want to print with only fiber, like forget about like plastics,
Mm-hmm.
then this is gonna turn like purple, and then
Oh, so that is just pure fiber.
just pure fiber, like yeah,
Wow.
no plastics. We could like look at like maybe some of those parts later, but we can. Do you want to show guys the
let's-
actual assembly line how we
Let's turn around and
assemble
show
the,
them. Everything okay?
machines? You're we good? Nice.
We're just gonna turn around. We're gonna go over
Yeah.
here. Just watch your cables. You're getting tied up there. Are we able to show this?
I think
Okay.
these are fine.
We're working on it. It's when everything is done live, there are certain things that can come into play that create. Let's go with challenges, huh? Yes, we do.
So here are the assembly lines, like sub-assembly lines for like different modules, right? So we have like print heads and print bed, like and then the PCB boards, and then over there is like the final assembly line. So here people like
Yeah.
assemble the small parts first, and then
These are machines getting assembled
These are the final-
right now.
final assembly line. Yeah.
What's the chance? And I have not asked if I can ask this question. I'm just going to ask it because I think it would be fun. What are the chances that we could assemble a machine while we're here? Not on stream, obviously.
Okay.
That is way too much pressure. But would it be possible for us?
Definitely.
Okay.
So I think we could give you like 20-minute training, and then we can put like maybe 4 of you guys in like different cells, and then let's see whether you could like assemble your machine.
Oh, so I can assemble my own machine.
Yeah.
So if it has problems, it's 100% my fault. I see what you're doing here. This is smart. This is smart business right now. This is really smart business. I like it.
No warranty. You have your own warranty.
I am the warranty. That's right. We warranty our machines. This is what manufacturing looks like. We've got stations here where when one thing is done, the machine moves down to the next station where the next person does it. So it is piece by piece by piece. Everything is on racks and carts and systems that make it easy to move around. And if the cameras pick it up, the floor is even marked with designated zones as to where you can move and where carts and things like that go. That way, no matter who is coming in, everything is where it belongs.
Yeah. So is
Mise en
like,
place, if you will.
on the final assembly line, there's like 10 like unit cells. Like yeah.
Now, how many machines are you guys able to produce a day here in the factory?
So I think like it. So the design idea is like the capacity should be like 3,000 per month. So that gives you 100 a day.
3,000 machines a
Yeah,
month?
With 2 shifts. Like
That's a lot of machines. Let's say, so 2 shifts, so you're
Yeah.
doing 15
yeah,
machines
yeah.
per shift per day, 30 machine. Wow. No, wait,
So we,
that's not
so
good
that's
math.
why even before the launch, we do
50.
a lot of like test production, not only to test the printers, but the idea is like we actually to really test the assembly line, right? Because you wanted like every workers, every steps to be like fully trained.
You
And
have to
then,
test everything.
Yeah, we have to test everything. So you want like all the cells are like coordinated correctly.
What's been the best learning experience from setting up manufacturing for a smaller machine? Because obviously, manufacturing the big machines, it's a little bit different. So what's been the best learning experience so far with the smaller machines in how these rooms are set up?
I think it's so different, right? With like big machines, it's more like handcraft.
Right.
Right, you don't really need like line to assemble like super big machines, and then you could afford the like working hours, assembly hours for like super big machine.
Right.
But since we're the consumers, the manufacturing cost, like the manpower you spend on each machine is
Right.
important.
Right.
So, so we did a lot of simulation and design from the day one when we designed this like whole floor.
So you knew that when you came in
Yeah.
here, everything was going to be laid out perfectly.
So we actually
Yeah,
worked
smart.
with like manufacturing like consultancies to you first design the floors. So you want the floor layouts like to be professional, to be like coordinated.
You need places for people to walk. You need places for things to go.
And then so you first design the actually so I love like what Elon Musk says, right?
Okay.
So he like design a factory. You know, it could be like should be more sophisticated than design a product. So I think like Tesla, they spend a huge like time and effort to design the factory. So the factory is a piece of art, but assemble like 3D printers is not as hard as like assemble like a Tesla's. But you still
or
like,
rockets or any of the stuff that he's working on
So you
these
still,
days.
but you still wanted to to optimize the process. It's all about process. So you would first design the layout of the factory.
Right.
And then you design the process of the machines. And then this process comes from together with the design of the machine itself, and then the process of how you make this each like part of each module of the machine. So you want like module design, right? And then you want like the process to be clear, and
Right.
then you design the jigs and fixtures for the assembly line to make sure you have the precision.
Yes.
When you put like this like rails and this like parts, right? These pads together, you want them to be
Everything
as
has to
vertical
fit
as possible,
perfectly.
or like as horizontal one to be possible. Like
Yep. And that means there's less tolerance when you're shipping machines. So you have less issues
Yeah.
with machines getting hurt in shipping because you've tested all of this and you have a standard
Yeah.
that's set.
So it's about like designing your simulations, and then you try it yourself, right? And then you find out problems, and you redesign, resimulate, and
Yep.
then you retry.
Yep.
Yeah.
Yep. It's pretty awesome to see the floor of where things are made. It's not common that companies in general will open their doors to content creators, especially when we're live and anything could happen. So this is Ryan, this is an amazing experience. If you all are enjoying this, please make sure to follow along to the FibreSeeker 3 Kickstarter. It is launching in literally a month.
Yeah, in a month.
It is 30 days from today because it's, well, 31 days because 31 days in October. It's in a month from today is when the Kickstarter is going to launch, November 18th, I believe, correct? Because that's the first day of 17th?
17th.
Oh, 1/7. Okay.
I know like
30 days from today.
Something might go wrong when you like show everything live, right? But I think I'd rather to be honest and transparent than I think even something go wrong, people would understand, right? But at least we try to be honest. We try to be transparent to our valued customers, like what we're working and what problems we're solving.
And if you know a little bit of history about us, we have a thing with making sure that companies are held accountable, that they remain honest, and they remain as transparent as possible. So when we had found out that we'd actually won the contest to come here, this was, and I'm like, oh man, we're going to show as much as we possibly can. And the idea of the live stream came up, we're like, we agreed to the live stream before knowing how difficult this was going to be. And it has truly been something that's opened my eyes, I hope yours as well, to see what manufacturing actually looks like for a, I'm going to put air quotes on this one and say a startup. Because Fibreseek is a bit of its own startup inside of an isoprint, right? Because the manufacturing for the big machines are downstairs. This is just manufacturing for Fibreseek on floor 2. There's more floors to this building. I have not seen any of them yet, so we probably can't show you. But they are currently expanding. There's a lot of things going on here. Are you guys looking for more people? If there's people local to the area and they would be interested, is there a way that they could potentially apply to work here?
Oh, definitely.
Yeah.
Yeah, we do.
You know, you happen to be in the Shanghai area and you're watching this for some
We're
reason.
hiring a lot of people.
Hire. They've grown their company over double in the last 12 months. That is a significant growth amount for any company, and they've maintained part quality throughout the entire thing. We've been checking. Do you have any other questions from chat? No? Is there anything else that you want to show everybody?
Yeah, so we could like walk through the different modules and then we can go to the testing rooms.
Sure.
So,
Sure. What's it say? Work with us, streams. I'm sorry. Wow. There's a lot of attention to detail being done here. Oh, the build plates are PCB.
yeah.
I didn't know that. Can I pull one out? Is
Yeah,
that
sure.
okay? Look at that heat bed. I see a, what's the technical term for this? It's like a thermostat, basically. It's a thermostatic switch. That's what it's called. Thermostatic switch, 110 volt, 1000 watt. It's a lot of heat.
Yeah, it's just to make sure it heats up faster. Right?
Wait, so you have a PCB on aluminum? That's pretty cool. I didn't know that was possible. There's so much about manufacturing that I still need to learn, but that is a big safety feature. You don't see this on a lot of machines. This is if something goes really wrong, this is what keeps it from going really wrong. This is an added safety feature that has an expense, because this is a manual process. This is not done by a machine. You guys are spending extra money to make sure that these machines are safe. That's something that we like to see.
Especially when you deal with like heating pads, like if this thing goes wrong, it goes like really off.
Safety is a huge concern, and it's why you've been seeing us take safety of 3D printers very seriously on our YouTube channel. And I'm very, very happy to see that Fibreseek agrees. Safety matters. That is super cool. I'm going to try to put this back the same way. That way I don't mess up the process.
Keep it organized.
Hey.
Yeah.
Love to see it. All right. Are we going to keep moving to the next room?
Sure. And then that's some of the...
Yeah, this is...
It's not like the biggest factory in the industry, of course, but like we try to be organized, and hopefully we could like expand later.
Looking forward to it. All right, let's move to the next room. Come along. Sorry, streams. It's going to be a little convoluted as we move.
Do you want to...
Huh? He's over there. All right, we're moving into here. Let's just go.
Oh, okay.
There's one cord. Thanks for putting up with this, guys. We don't normally do live streams where we move around offices, but we're making it work. All right. I have been given approval. How many likes are on the stream right now, Amber? Can we see that? How many likes we got?
42.
Only 42. How many people are watching right now? Up to 60. It is late. So if we can get, let's get 65 likes. If we can get 65 likes on the stream, they have allowed me to do the peel for you. Otherwise, it will stay here, and I will point it out to you constantly that it's your all's fault that we're not able to peel it. So, we have a running machine here right now, but we also have some functional parts sitting here. Let's take a look at these parts.
So that's a hook.
That's a hook made of
Pure fiber.
pure fiber. There's nothing in this but pure fiber. Wow.
And that's a drone actually we designed.
see,
That's my favorite.
Yeah, I was saying, this is really what I was wanting to take a look at. This drone is, this is something. Wow, this thing is really lightweight.
It can fly. Yeah.
You do not want me to fly this. One, I'm not certified. Two, I would probably crash it. But it's funny because even if we did crash this,
it's actually designed for crash. So
it probably wouldn't break too bad. But I'm not trying to, be the person that's flying a drone without proper approval. At least in the States, if we do that, 3-letter organizations get involved, and we don't like that. Okay, so we've designed a lot of drones in the past, and this is a 250, right? 250 class? 250 millimeters from prop to prop?
Yeah.
Looks about 250. It could be a little bit larger. This is one of the lightest drones I have ever held. And it's probably one of the strongest as well. Now, there are some...
I'm so excited to see like drone makers globally, to play around with technology and then design your own drones. So it's going to be fascinating.
Globally, wink, wink. You all know what we're talking about. Now, there are some limitations to where you can put chopped the continuous fiber. What are some of the limitations of continuous fiber when we're looking at designing parts?
So like I think there are like some constraints. We set it up in the slicing software, but they're mainly like the wall thickness. So you don't want to design a super tiny part, right?
Yeah.
So like
you have to have some wall thickness.
Tiny, you have to have some room for the fiber to be like laid, right? And then you don't want like super like sharp corners.
Right. Right. Fiber doesn't like going around sharp corners. They'll have a tendency to pull away from them. So, Chris, if you're watching this, you should add fillets to everything with continuous fiber so it's a smooth curve and not a sharp one. There are some people in our Discord that make fun of me because I like to add fillets on everything and make the edges really smooth. But a lot of that is kind of from when I used to own continuous fiber machines. And do you know why we got rid of continuous fiber machines at 3D Musketeers?
Why?
They were too expensive. They were too expensive to buy, they were too expensive to maintain, and they were too expensive to run. The parts that we could produce on them were so expensive.
But you did like the parts, but it's just you couldn't really afford to.
Our target market could not sustain it. It was too expensive. Fibreseek all of a sudden means, well, wait a minute, we can now offer continuous fiber again to our community for not a whole lot of money.
And you don't have to worry about how much fiber you use because they're not like so expensive, right? They're quite affordable. And
that was a fast movement. Sorry. Yeah, this is, for those of you that like to fly quads and drones, especially, I'm looking at you all in the aerobatics industry, the ones that like to, the FPV things that I watch on YouTube when they're flying through buildings and I'm afraid they're always going to hit something and they never do. This is where continuous fiber comes in because you can make your drone lighter and stiffer at the same time. Normally with drones, you have to play this game between stiffness and weight. Yeah.
And then I think the best part of Fibreseek is when you design the drone, right, you could design the fiber like in the lattice structure. So that's something only us could do. Like no other, I think, manufacturers offer this possibility. Yeah.
That's so cool.
So the fiber is already light, and then you make them go across each other. So it's like, and then you can play around in the software how much infill, like 20%, like or 60%, or like 80%, right?
Well, and if we look at this,
fiber, right?
This is, so if you compare it to other major continuous fiber manufacturer on the market, this is bigger than their build volume. This would not fit on other continuous fiber machines. There's only one. There's only one other major brand. Okay.
Normally, they only do like is you lay the fiber with solid fill. That's like a lot of fiber. So
But I'm
it's
saying
cool-
this
yeah.
is too big to go in other
right.
machines. Your machine is big. You can do 300 millimeters in the X and the Y, and still have continuous fiber.
yeah.
That's pretty amazing. And yes, continuous fiber in the infill, so you're not just stuck with the perimeters.
Right.
Actually, wait a minute. This is only in the infill.
I think it's infill plus the.
There might be the
parameters,
one inside perimeter, but the outside
So in the
perimeters don't have
software,
it.
we do have the options for like parameters, and then for infills, you could like reinforce either the parameters or infills or both. Yeah, so it's an option.
And so the slicer, is there any cost associated with the slicer?
Not really.
I like
So
those
we
answers.
just have like two kind of versions. One for like beginners, so like you have less control, but like the computer like
It's easier.
does the job. That's
Right.
like the computer define all the fibers for you, right? How to put it, where to put it, like how much you want it. So you just have to pick the strengths. You want like a little bit of reinforcement, medium reinforcement, like you want like strong, like higher reinforcement or like full reinforcement. So you just select from the bars of the strengths.
That's
But we
amazing.
have like a professional modes, which you could just define the parameters. But like I suggest like to play around with beginners for some time, and then you go up with more experience.
But you can make practical things.
Yeah,
I mean,
yeah.
not that we would ever recommend printing a hammer because you can go buy hammers, but if you wanted to, you could.
Yeah.
And this will actually hammer in nails. They have videos of this on their channel. Go check it out if you haven't seen it yet, where they take a hammer just like this and they literally hammer in nails because the continuous fiber makes it a much, much stronger part.
And we do have like bottle openers too.
I'm
if you
told
want
there's a demonstration for the bottle openers.
Do you want to try it? So are you thirsty?
I mean, always thirsty. So there is no metal. There's no metal in this.
It's just some like reinforcement around like parameters. So yeah.
There's just continuous fiber,
Just a
and it's
little bit of
only
fiber.
on the outside. Okay. Let's see if Grant still remembers how to open a bottle. There we go. Done. It's not even difficult. It is not even difficult.
Okay, so let's have some of my favorite soda.
This is your favorite soda?
Yeah.
Okay.
I bet you don't have this in
The cups are branded. The freaking cups are branded. No, we do not have this in the US. I don't even know what this is. Oh, this is lychee, isn't it?
yeah, it's lychee soda. Cheers.
Cheers.
Welcome.
Oh,
How it tastes?
I now know why this is your favorite. Oh, that's really good.
So shall we
really good.
grab a seat, and then I guess we have some Q&As or anything else you want to show?
Sure. Yeah, let's grab a couple of chairs. Let's 61, and we need 4 more, and then I'll do the peel. Thank you, thank you. Where do you want us? Oh, over here, in front of the machine. That makes
Cool.
more sense. Oh, we're going to read the chat. We're going to read the chat live. Yeah, give me these. Again, a huge thank you to Fibreseek for bringing us out. We actually won the contest. I wasn't expecting this, but they had a contest. We ended up winning it, and I did. I applied with my personal email. I'm like, I'm going to enter with my personal email and see what happens, and we won. And so
Congratulations.
when we got tagged, it was tagged as my personal Facebook. I'm like, oh, wait, I won. Because I don't ever use my personal Facebook. But yes, so huge thank you to Fibreseek, and check out Fibreseeker 3, obviously, for flying us out all the way to Shanghai. Literally we are 12 hours off. So currently, what time is it back home? It's 10:45 in the evening back home.
And then East Coast, right? So,
Yeah, East Coast. So what do we have for, what do we got for questions? We have a live Q&A, guys. So what do we got? Max bed and nozzle temperature. So what do we got?
Sorry, max bed and nozzle. Okay.
So yeah, max temperature for the bed and then max temperature for the nozzle.
I think max bed temperature is like 100, and then the for the nozzle it's 350 for both.
Oh, 350.
Yeah, 350.
So you can push, you'll be pushing nylon. And that's traditionally when you look at continuous fiber, it's nylon. But you guys are not locking it down like other manufacturers. You're saying if you want to do continuous fiber with PET,
PET and like I think recently the PPS or PPA or PPACF has been
Yes.
pretty popular. Yeah.
and it's
So
not
I think
chalk.
it's cool to have the possibility also to bring with like a bit higher temperature. So
350
I think
unlocks a lot.
350 and
It
then
unlocks a
like
lot.
a heat chamber with like 65.
The heated
You can
chamber would
print
be a
like
big
a lot
deal.
of the materials like below peak, right?
Yeah.
Yeah, with peak you need like 200 like chamber, right? But with PPS you can do like 65 chamber temperature without warping.
You can do the
and
bells
then-
that with
yeah.
PPS. If you guys don't know PPS, it is a polymer, it's a plastic, but when you extrude it, it sounds like metal. It rings like metal. So what do we got? What do we got?
Question about toe radius for diameter.
I don't, toe radius or diameter.
I think they might be referencing the amount of squares.
Oh. Yeah, so what is the sharpest corner that you can get with the continuous fiber? What is the recommended radius of the corner?
So the sharpest corner, so it can actually go rectangular, but like we do it like differently.
So what's the recommended radius? A recommended curve. How much curve?
Diameter at all.
Yeah.
So
The diameter of the toe is above my... I have business degrees, I'm sorry. 0.08
0.08
is the answer.
Oh, you mean the diameter of the raw fiber?
Oh, the diameter of the raw fibers, it's...
Raw fibers, like you mean the toe inside of this like CCF filament
Yeah, what is the diameter of the continuous fiber?
of the impregnated filament is
Yes.
I think 0.3 millimeters.
Okay.
Yeah. But that has like 1,000 strands of like raw fiber in it. That's why it's 1K, right?
Wait a minute,
1K
wait a
is
minute.
the term of like composite materials.
0.3 millimeters has 1,000
1,000
strands.
strands, like small strands. So each strand is probably like 1 or 2 micron.
That's why that part was so hard to break. That's a
So
lot
if
of
it's
carbon
1K,
fiber.
it's 1,000 strands. That's how
Uh-huh.
they define it. If it's like 1.5K, it means it's 100.
The 1,500,
yeah,
1,500
strands.
Wow. And there are some pretty interesting parts. I mean, the wrench is the video that you guys have done too, where you actually used the wrench and did that properly. What other
I
questions
think
do we have?
got like what firmware
What
does
firmware
the
does it
FibreSeek
run on?
It does run like on the Clipper.
Okay, it does run
Yeah,
Clipper.
yeah.
So it will be open source?
Yeah.
Okay, very nice to see. That's nice. I'm glad that you guys have chosen Clipper for that. I have a question. Will there be support for third-party slicers? So could I use like Orca Slicer with the continuous fiber? Like, is that ever going to happen, you think?
Not like in the near future, like in
Okay.
next year, but because slicing is like FDM and then slicing is fiber, right? It's quite different.
It's a little different, yeah.
And then we really develop from the scratch the algorithms of how how you do like the geometrics, like path planning for the carbon fiber.
Okay.
Yeah.
But your slicer is free, correct?
Oh yeah, they are.
Good enough for me. Good enough for me. What other questions? Do we have questions on YouTube?
Tell Ryan thank you for putting this on.
Who's that from? Okay, so Helix says thanks for putting this on, Ryan. Thank you.
Tripod's garage and also see you.
Oh, Tripod's
Hi,
here.
Tripod.
You went and visited him,
Yeah,
didn't
yeah,
you?
Yeah. We had some like deep dishes together. That was fun.
Okay. All right. You've had deep dish. How do you feel about deep dish pizza?
I loved it.
Okay.
Yeah.
Okay. See, deep dish to me is the embodiment of a pizza pie. Because it is a pie. You need a fork and knife to eat that. I love it though. It's good.
Yeah.
Do you have any other questions from chat? Come on, guys.
How much fiber per spool?
It is 500 meters per spool. How much weight is that?
I think probably like 300,
Okay.
300 grams.
It's so thin.
Yeah.
I don't know how you're packing that much fiber into such a small space. That blows my mind.
You mean how we roll it up?
No,
or,
no. That's 1,000 strands in 0.3 millimeters. That's tremendous.
So actually, we didn't do the. To be honest, we did just packing. So there are tons of like raw fiber manufacturers. Like if you have heard of like Torii or whatever, like
That is a benefit that you have of being in
hex,
Shanghai.
yeah.
You're quite close to all of the major manufacturers in.
So the raw fibers we received are already like 1,000 strands, like per a big strand, right? So we pick the 1K grade, and then we just do the post-processing for these raw fibers.
We have another question? What do we got? Question, for the Kickstarter, are you going to do any stretch goals? Do you know what a stretch goal is?
So the goals like you put on the.
Yeah, so so Kickstarter has a regular goal, right? So let's say it's 50,000 or 100,000 for the regular goal for Kickstarter. There's then a stretch goal. So if you hit 500,000 or 1 million, you give something else, right? Whether it's a spare nozzle, extra of the carbon fiber monofilament, that kind of stuff.
Okay,
Are there planning for stretch goals so that people can build up the hype for the machine on Kickstarter?
I actually haven't thought of this way, but I think it's an excellent idea. So
I think it should be done.
yeah, it should be. We should do that. Yeah.
Let's see what else we got here. How long did it take to develop the FibreSeeker 3?
So the original plan is to did like in less than a year, but it does actually take way more than a year.
Took a little bit of time.
Yeah,
Huh?
always.
Now, when did you start developing this? Do you remember when you started developing FibreSeeker 3?
So yeah, so that was like I think last year, mid of last year.
Now, the name FibreSeeker 3, that would tell me that there's a 2 and a 1.
So that's a golden question. It's like the question that everyone confused or like wanted to ask. So and I have waiting an opportunity to really give the answer, and then I think no one could like really think of. So why there's no FibreSeek 1 or why there's a FibreSeek 2?
Right.
So in the morning, did you see which car that I drove to the factory?
I didn't see it.
So I come with like Tesla Model 3.
Okay.
And I super love my car. So I think like, Model 3, right, was the first car that democratized electric vehicles. So before you only have like expensive Model S, which is like not that many people could afford it. But with Model 3, you see like electric cars everywhere. Like nowadays, especially in Shanghai, since we also have like Tesla Gigafactory in Shanghai, right? So right in Shanghai, half of the city, if you like, we take you to travel around, you see like half of the city drives like EVs.
Okay, I'm a huge EV fan, and we've been in a bunch of different, I'm gonna say taxis, but they use an app called Didi here. It's kind of like Uber, but in China. Almost every vehicle that we've been in has been electric, and every single driver that we've driven really enjoys the fact that they get all the horsepower and torque out of these electric cars. There are so many electric, and they're designated with license plate colors. So different color license plates designate what type of vehicle they are. The electric vehicles get
the green
one.
Green plate.
And that's super cool. And there's so many green license plates. That's
so FibreSeek 3 is like the to democratize continuous fiber, like Model 3 democratize the EVs. So I would rather call it.
So there isn't a FibreSeek
3.
There isn't a 2 and a 1.
To my car.
So
Yeah.
that's why it's a FibreSeeker 3.
What is three?
Yeah, 3, Model 3.
Yeah. We just asked that.
Yeah.
And so FibreSeeker from the company FibreSeek, is that because this machine is always looking for a continuous fiber part to make?
Sorry? Yeah.
The name FibreSeeker
Yeah.
for the machine, is that because it's always looking for a continuous fiber part, or why the name FibreSeeker for the machine itself?
Yeah, so when you have like super expensive machines, so you don't seek to print with fiber, right? Now it's available, like it's democratized. So we seek to print with more fiber, and then we seek to see what parts people have print with fibers. Yeah,
Okay.
so that's that concept.
Someone asks, are we going to only have carbon fiber component, or is it any fiber, like glass fiber or something else?
So the question was, will it only be continuous carbon fiber, or will there also be things like continuous glass fiber, continuous Kevlar, and other materials to embed? What is the plan there?
Oh, certainly. Yeah, fibers. That's why it's FibreSeek, not carbon FibreSeek, right? So
You took the
fiber-
joke from me. That was literally the joke I was going to use. It's called FibreSeek, not carbon FibreSeek. Yes, there are plans. In fact, there are rolls that we've seen here that
I
are
think
not
Eric,
carbon.
we have like glass fiber as well. So maybe Eric could grab one for me. I could show to the
But
guys online. Yeah, we have.
it
glass
looks like the
fiber, we have-
carbon. It's just not black. That's
Yeah.
and don't poke yourself with it.
So different fibers have different like properties,
Mm-hmm.
right? Yeah.
Are you able to print with both chopped carbon fiber and continuous fiber in the same print?
Yeah. So to print with chopped fiber is no different than printing with like.
Right. Oh, this. I thought
FDM.
you were gonna hand me a reel of it. No, you hand a
Yeah, it's
part,
really part. Yeah.
with the glass fiber, with the
So,
continuous
maybe we
glass in
could,
this.
say it to.
Here, I'll bring it up and show the cameras. We got this one here.
So inside that's
We got
like
that
glass
one
fiber,
there.
but it's also a white color.
And that one there. Yeah, lots of that lighter white, almost eggshell. That's glass. Wow.
But like glass fiber is not as so. Yeah, we have the.
Oh, okay. We got the
roll
roll
as well.
too. There you
Yeah.
go.
You might want. I can. So the package looks the same, but I can open it up. So
Wow, that is such a thin
yeah,
line.
yeah. It actually feels different. So it's a bit less stiff than the carbon. So
Oh
you
yeah,
could,
it's,
like,
it's
twist it a
much
bit
thinner.
more, yeah.
Oh,
I mean,
it's
like
okay.
not
It's much more flexible.
flexible. Yeah. So that's glass fiber.
It's almost like an optical fiber. That's pretty amazing. So at launch, will you have the glass fiber available?
Yeah, I think. I'm not currently sure because we have like capacity for like carbon fiber right now. So if in case we have like more capacity for like glass fibers, we will announce it. Yeah.
And so, is there a known price for the glass fiber in the 500
It's
meter?
not yet finalized yet, but yeah, it should be like quite cheaper than the carbon fiber.
Always like to see when materials can be made more affordable. That's what we love here. Any more questions? If not, I've got a whole list of them. Ooh, how much resistance does the carbon fiber have? So is it electrically conductive? And if so, how much resistance does it have?
This is quite a
That's a very
specific-
complicated question.
specific question.
Who asked that? John Stern. Could you use the continuous carbon fiber to make wires in a 3D print?
You mean with carbon fiber wires for?
Using the continuous fiber and then put an electrical current through it as a wire.
In this case, you don't necessarily need to use carbon fiber. You can print with like copper fiber. So yeah, I think with our machine you can also print with like not carbon or glass fiber. Yeah, you can do like. I think copper fiber works better than carbon fiber.
I mean, yes, copper fiber would work a lot better than carbon fiber. I didn't know that was an option.
Yeah. It's just like not very, commercialized yet. So I think it's a bit trickier.
Carbon's gonna
print,
have
so
a lo-
we don't like support to like every customer, but if you like, I'd like to like DIY. So it's definitely possible to print with copper wires or some like metal wires, and I have done it. I think I've seen one of like the professor, the customer we have like at a nice printed with copper wires, and it looks pretty interesting.
That'd be pretty cool. And yeah, so John, there's going to be a fair bit of resistance. Carbon fiber has a fair bit of resistance. That's just part and parcel for what carbon fiber is. I didn't know that you could do copper.
Yeah, because with carbon fiber, the thing is like in order to make it print easily, we already added some like coating on it, like epoxy coating. So I'm
You
not
have to
sure
grind that
the
off, yeah.
resistance, like the pure fiber is definitely like electric like conductive, but like to mix with like resin, so it's like already a composite material. So I'm not 100% sure the actual resistance. But if like people are do looking for, print like wires, then I would recommend to get some like copper wires and print it. It's definitely gonna work.
That opens up so many.
Yeah.
Okay, I was not. There's been a lot of things that I'm getting surprised about too. The fact that copper is possible. My gosh, I can think of so many use cases of putting copper in a part, and I'm looking specifically. It was such a good holder for the sign.
Path planning the same as like continuous carbon fiber. You
Like-
use the same slicing software, so it gives you the same like path.
I'm thinking drone parts, but we've got all these wires running through here. If you did continuous copper, you get strength and electrical conductivity. I have a lot more ideas now. What would you all do if you had access to a machine like this? What would you make with it? Would you make drones? Would you make tools? What would you make?
So I didn't expect there more like interest from people, because like I only seen it in like research areas, right? So if there's more interest, maybe we have like a new project to work on. That's fun though.
I will tell you, John Stern specifically, he often asks very, very technical questions, and he does a lot of research in this space. We have quite a few people that watch our channel that are very technical. They do what we would consider additive manufacturing and less on the 3D printing. And this is probably the first machine in a long time where the line is really blurred for me between 3D printing and additive manufacturing. Additive manufacturing normally comes with like at least a $10,000 price point, if not more. Air filtration. Is there air filtration on the machine?
Yeah, they are.
Okay. What are you using for air filtration?
So when we add a heat chamber, right? So it's not like only a heated chamber. It's also like a cooling fan. So,
Right.
And then it filtrates the whole like system inside. Yeah.
Wow.
We do.
Nice. And the chamber heater is something that's coming. These machines do not currently have it, but chamber heater is on the
They're
way.
like 100% on the way.
I love that. I love chamber heater.
And it can
machines.
cool down the like print head itself, right? With this like cooling, and then with like ventilation system.
Very nice.
So when you print with like low temp material like PLA and PETG, the idea is like you don't have to close the lid. Right.
Love it. Love it. Love it.
Oh, so you don't have to open the lid. Sorry. Yeah.
Yeah. Even though you don't have to, it's like burned into my head that when I have an enclosed machine and I'm printing PLA, I have to keep the door open. Now, what's the door made out of? What's this door made out of?
I think this is
Can I open it?
acrylic. Yeah. The door.
Yes.
Yeah. Acrylic.
So Uncle Jesse, Clayton, hey, it's acrylic, man. You're not gonna break the door. Is it printing right now? Oh yeah, it is. Yep. Can if you want. It's very slow right now because it's doing the continuous fiber. Yeah, there's no way you're going to be able to see it printing continuous fiber, but you can definitely turn the camera and zoom in if you want. Now, how many likes do we have right now? I told him it's 65 likes, I'm peeling it. We have 64. It's not good enough, guys. We got to get to 65. Mm-hmm.
Use cases, best use cases for continuous fiber.
Best use cases for this machine, you think? What do you think?
Like the best use case?
What do you think the best use case for a FibreSeeker 3 is?
I think it's hard to like define what is best because like different people have like different standard, and it depends on like which the industry you're from, right? For like in the old times, the best application for this would be like jigs and fixtures for like manufacturing lines, and we work with a lot of like big factories, and then so you have this like carbon fiber printed part to replace the aluminum like jigs, and then so it's easier to transfer, and then it makes the assembly line move faster. But that's more like in B2B we talk about application. But when this machine is affordable for like more like prosumers or some like consumers for like personal use, like I think for drone makers it's probably the best application for like drones, but for me the
It's
best
an easy
application
option
I said
for
is like
drones.
I'm printing like car parts, so I'm like car person. So
I
that's the
want to
best
print
application
car
for me.
parts.
Yeah.
I drive a 23-year-old Honda.
Yes.
There are many parts on that car that I could 3D print out of continuous fiber. There's many parts on the car that I have already 3D printed. But with continuous fiber, they won't keep breaking on me. So I am told we hit the like count. MET? What is MET certified? I have to grab my phone and I'm gonna have to Google what MET certified means because I have no clue. Yeah. Because I don't know what MET certification is. So let's see what it says. Okay, MET certification is most commonly referred to as a MET mark. It is a safety certification for electrical products that indicates compliance with North American safety standards recognized by authorities, retailers, and consumers in the
I
US
think we
and
do
Canada.
because I'm not like in the details, but what I know that we do apply for at the moment for all kind of application certifications.
Okay.
Yeah, I think we should have like on the process of like applying this one.
Now, we hit the like count. Am I able to? Well, I got to get 69 now. I mean, all right, fine. You guys did it. So let me do the peel for you here, because I know that all of you want to see the lovely acrylic panel. Oh, there's a lot of sag on the front of the machine. There you go.
And see, yes, definitely.
See, now it doesn't bother you anymore. Thank you. What other questions do we have? Oh, yeah, camera mounts. Dale says Grant lawnmower blade. Grant's going to do a lawnmower blade with it.
Long blade, I think, yeah, if you design it correctly.
Yep. Oh, you want me to go ahead and open this? If you want, you want to pop the camera off? And, okay.
Yeah, we are going to be at FormNext. On the same day, we're launching the on Kickstarter.
And DevMiner, I know, will be at FormNext. So DevMiner has told us that they will be at FormNext. So we know about that.
So yeah, Boost 12.1.
Best uses car parts because race car, modular intake manifolds, like what I'm working on for my flathead Ford. You can probably do most things short of
Oh,
modular
I think we got a
chassis.
question. Why this strange door shape? I would love to answer this.
Okay,
one.
yeah, why the strange door shape? It is kind of a strange shape, I'm not going to lie.
You know, when talk about the door shape, right? So I want to design a printer that is unique. So if you like look at this angle here, so it's actually a reflection of this shape of. We also have a strange like shaped
Yeah,
screen.
the screen.
And these are all the same angle as this like rockets.
Oh, as the rocket.
Yeah.
Okay.
So that's a design code.
It's just a choice. The answer is because you can. Why the design choice? Because you can.
So the thing is like, you know, this technology was invented to like definitely to make rockets and like spaceships, right? So that's why our logo is a rocket. So the shape of the screen and then the shape of this door are all lined up with the shape of our logo.
So John Cern asked an interesting question. Can you print a part that won't fit through the door? Is that possible?
Well, you can open the lid and then
Pull it out
remove
the
the
top.
part like
Yep.
over the top. If you print like a full size, yeah.
I don't think that you can. So it looks like the entire width is printable, but it's not. The plate is only 300 wide. I would say this part is at least 350 to 400 wide. So even though the bed looks a lot larger, it is limited, and it does not appear to me that it could get stuck. Dev Miner asks, is there already a shipping date planned? I know we discussed like Q1 of 26.
Like February, yeah, 2026.
Oh, okay. They're telling me that I have to take off the inner door peel now too. The orange light. Yes. So what is it with the lights? The lights are cool, but why are they cool?
Yeah, so we have three colors, right? So we have orange light, we have green light, we have purple light. So green light for like pure plastic springs, and then orange light is when you embed fiber in the plastics, and then you have purple, which is maybe you might want to show the hook to the camera. So if you want to print something like this,
Yeah, if you wanted to print in pure fiber.
yeah,
Yep,
and
you
then
want to
it's
print
gonna
something
be
in
purple.
pure fiber, that's what it ends up looking
So
like.
it's just to demonstrate, indicate like what kind of part you're printing. So if you run a print farm, that's going to be easier to operate.
Versus something like this that has some continuous fiber in it. Is there anything here with no continuous fiber? No. Versus a regular 3D print. All right, Amber, can you move the camera so that they're yelling at me because I only peeled the outside. I will peel the inside here. Just got to make sure that we get the camera shot. Because this is what the internet wants, okay? What the internet wants, we give them. Ready? Yeah? Okay. Oh, this is a good one here. I got my mic up to it. You're welcome. What? Oh. So when we look at what it's doing right now, it is currently laying the continuous fiber, correct?
Yeah.
And that's why it's moving slow. Okay. Looks like some people want all the peel off. I leave it on as long as possible. See, David Connershover's like me. I leave the peels on as long as possible.
That's the light changing color. Oh, so when the print is over, it doesn't change color, but it flashes.
Okay.
So it tells you it's done.
Okay.
Yeah, yeah. That's a question from Gregory.
Very nice. Any questions from Facebook? No? Okay. Huh? Regarding? Yes, they'll be at Form Next. We answered it. Yeah. Are you guys offering passes for people to Form Next? Do you have any tickets to give away for Form Next?
Do we?
No? Okay. Sometimes companies have tickets for Form Next. So now
Okay,
close
so
it so
yeah,
we
yeah,
can see.
we will do some like lucky draws. So I think we can offer some like free tickets.
Okay.
Yeah.
I actually like the styling of it. Where did the logo come from? And then you decided to build it in with everything. Like, where'd the idea for the logo come from?
You know, I personally designed the logo, and
Mm-hmm.
I in the beginning I tried to hire a agency to design the logo, and then I didn't like any of their options, so I'm like, let me do it myself. So I just like combined the concept of like rocket like science and technology,
Mm-hmm.
and it's a lattice structure like of carbon fiber, right? So it's a rocket printed with like lattice structure. It's carbon fiber. That is the uniqueness of our technology,
Love it.
and then I put them together.
So Ryan, are there any final thoughts you'd like to leave the folks at home with before we end the stream and we start actually filming in here? There's gonna be a lot of videos coming out. So subscribe to 3D Musketeers if you haven't yet. But is there anything else that you'd like to leave the folks at home with?
Yeah, I mean, really, thanks everyone for like, I think in the East Coast or like the people like staying up late for this stream.
It is 11:15
Yeah.
in the evening back home right now.
And thank you so much for the engagements. So yeah, what I wanted to share like is just I think it's a wonderful opportunity
Right.
to bring this technology to a more like big audiences, to explore more opportunities. And I'm eager to learn from the audiences how we could make it better. And I'm also eager to work with everyone to find out like what kind of like cool applications we could develop. And I'm looking forward for more insights, like the idea of this like copper wires, right? I think that's only cool ideas only coming from the users.
So
So we could find more. I can find more like interesting stuff to like reignite myself for like the next project. So what I want to say is it's just a beginning. I'm really looking forward for like wonderful journey with everyone.
So Helix asked if they're going to have a Discord server. We will talk about that with them off camera. I don't want to put them on the spot for that. But I know you have to get back to work, Ryan. It might be a Saturday, but you've got work to do, right?
Yep.
So
So we're like trying to, work day and nights to make sure this thing really deliver, right?
Yep.
Yeah.
Yep. So if you guys want, I can hang out and talk on the 3D Musketeer stream for a little bit. If not, we can go ahead and end them all, and it's up to you guys.
Yeah.
Let us know what you want. Did you want to wrap it up?
Okay.
Okay.
So I will say goodbye to guys. So
Yeah, absolutely.
thank you guys for joining. Yeah.
Now, we have an outro that we normally do. Would you like to do it?
What's that?
So we normally say something when we close out a video. Would you like to close out this
sure.
video?
Sure.
So we stay safe out there.
Mm-hmm.
Don't forget to call your loved ones. And as always, keep making awesome.
Mm-hmm. Okay, let's do this.
Do you want to say it?
Yeah.
Go ahead. Stay safe
Stay
out
safe
there.
out there.
Don't forget to call
Don't
your loved
forget
ones.
to call your loved ones.
And as always,
As always,
keep making awesome.
keep making awesome.
Take care, everybody.
Thank you.